Hi, everyone, and welcome to the USC Viterbi School of Engineering Faculty Roundtable session. Today, we are talking about computer science and the Thomas Lord Department of Computer Science. My name is Paul Ledesma. I am the Executive Director of Undergraduate Admission here at the USC Viterbi School, and I'm joined by two of our profound faculty members in the Computer Science Department. I'm going to let them introduce themselves here in a moment. But before we do that, I want to tell you a little bit about what we're going to be doing today. Today, we're going to be talking about everything related to computer science, a little bit of computer engineering, everything that has to do with computers here in the Viterbi School of Engineering. We're going to be going through a bunch of different questions that I've laid out that will, I think, lay out a bunch of different opportunities for you to learn more about this place. And then in the latter half of the hour, I'm going to give you an opportunity to ask questions, and we're going to open up a Q&A function at that time to be able to ask your questions and also make sure that we cover everything that you want to know. So for right now, sit back, relax. There's nothing you need to do other than listen and be entertained and learn more about our program. I'm going to give you a heads up when we're going to open up the Q&A function at that time. And when we get to the Q&A function, I'm also going to ask that we're not asking questions about admission or the application process, because this is strictly about computer science as a discipline, the department, the majors, the classes, the research. That's what we're going to get into. If you want to sign up for one of our admission events that we have regularly, we have those. I'll put a link in the chat for you to sign up for that. But without further ado, let's get to meet our faculty here. First, we'll start with our faculty looking to my left, which is on the screen here, Professor Halfond.
Hey everyone. So my name is GJ Halfond. I'm a professor here in computer science. Very broadly, my area of research is in software engineering. So I develop automated techniques that can test and analyze software for different kinds of security vulnerabilities or other kinds of failures and faults. I've been at USC for a while now and I really love being here. But I'll stop there and maybe tell you more about that in the Q&A, and I'll turn over.
Andrew.
Hi, I'm Andrew Goodney. I am teaching faculty at the Computer Science Department here at USC. My research was broadly in computer networks and computer systems, but after my PhD, I decided to go in the teaching track, which is a little bit different way to be a professor at a university like USC. It means that I don't have a sort of day-to-day research program. But it also means I teach more classes and I really get to know our undergraduate student body pretty well, because students sometimes have me one, two, or even three, sometimes four times over the course of their courses here at USC. So it's actually one of my favorite parts about being faculty is getting to see students come in their first semester and then being at graduation to see them head out the door. So thanks for coming to check out the Viterbi School.
All right. And to be fully transparent, if you've joined us for one of our other faculty roundtables, we typically have a third faculty member, and unfortunately, that faculty member had a little bit of a family emergency today, was unable to join us at the last minute. So, but we still get Professor Halfond and Professor Goodney here to be able to chat with you about the program, and I'm confident they're going to do a good job. I said that they're going to have to talk a little bit more now that we're missing one faculty member, but you got some great guys here to be able to chat with you about this. So my first question, and then let's just go, whoever wants to pick it up, because I'm going to ask what's seemingly a simple question, and I'm sure you're going to have different answers to this that are a little more broad and complicated. But what is computer science as a discipline? And, I think I'll add a couple elements onto that, which is, from a high school perspective, students have classes called computer science or AP computer science, or maybe they've been growing up coding. Maybe they went to Khan Academy, and maybe they've actually taken their own courses in Java or maybe even C++ or Python, whatever you're going to get into. What is computer science at a college level? What is this degree program about? What's the discipline about? How do we start explaining what this is, even to someone who doesn't have any of that background and someone who maybe believes that they have all the background?
Andrew, do you want to go first on this one?
Sure. Because we talk about this in the intro classes. Certainly something we cover, because we get students who they have that background like Paul mentioned, or they have none of that background that Paul mentioned. And so we like to work with both types of students across the spectrum of previous knowledge. And I like to tell students that computer science is about solving problems. And if you want to be a little bit more specific, it's about solving problems with information. So you have some information, you have some data, you want to do something with it. How do I do that? How do I get a computer to figure out how to solve this problem for me. And that's when we start getting into all the different subdisciplines about, programming, which is what I teach. There's algorithms and computer science theory, which look at problem solving more in the abstract. And then from there, we get to things like software engineering, robotics, networks, graphics, AI, all of the sort of buzzwords that you may have heard. But at its fundamental, sort of lowest level, computer science is about developing solutions to problems that are then executed on a computer to, usually answer a question, or do something useful for, us as the programmer or computer scientist.
Yeah, I'd like to echo that. I really think computer science is about solving problems, but from a computational perspective. So bringing in computational thinking to bear on different kinds of problems. And I think a common misconception is that computer science is about programming. And once you learn a language like Java or Python or C, that you have mastered computer science. And in fact, I think that's equivalent to saying I know how to grow a plant, therefore I should get a degree in biology. And there's a lot more that goes into this study, learning the kinds of algorithms, how to recognize different kinds of problems and solutions that have been developed before. And importantly, how to develop large-scale software systems, which is, when you're talking tens of millions of lines of code, that's a different kind of approach than it is to develop throwaway hobby applications that are maybe a couple hundred or a couple thousand lines of code long.
Yeah, I think one thing we might want to address right off the gate is there's so many rumors and things and stuff that I hear all the time. I'm sure that you all hear a lot, which is CS is dead. It's not a degree program. We have AI now, so why would we ever need computer science? And the three of us know that this is a ridiculous statement, but how do we shed some light on that for our audience?
I mean, the first way to look about it is to say, well, who wrote the AI?
Yeah.
Right? Someone who was in my PhD cohort at USC was instrumental to creating the sort of Gen AI that we have now. Some of the research that he built on at USC when he was at ISI, when he went to Google, was directly turned into the technology we have today. And so to step back a little bit, or maybe try to look in there, the AIs that we have are really good at doing some things, and they're really bad at doing other things. And one of the things that they're bad at doing is being creative.
Hmm.
So they can reproduce things. They can help you write code for a language that maybe you've never written before, or you wrote, you haven't used this computer language in 20 years and you're trying to catch up. It's really good at those sort of things. But they can't invent things. They can't make new things, because they really don't have a way to do that. And so computer scientists, at least for now, are going to be needed to develop the next version, to take the AIs and continue to make them useful for other parts of society, right? It's the fact that AI is good at coding doesn't mean it's necessarily good at driving, right? And those are two different uses of AI that we're seeing all of the time. And the type of AI that goes in the Waymo is very different from the type of AI that goes in, your chat GPT. And so I don't know, if I want ChatGPT writing code that goes in my Waymo without a human being in the loop there, right? That's a really important thing to do. Write code that drives a car autonomously on the road with all of us, right? So is the computer science landscape changing? Of course. Does any field sit still and not change? No, all fields change, right? That's part of the excitement of being at a university and learning about a field, is to see where it's going, and because that's where you're going to be as a student. You're just getting started, right? So you want to look ahead and see, where am I going to be in this field? And I think computer scientists are going to continue to contribute to understanding how to make computers do what we need them to do. And if that means, because of certain types of AI, we actually physically write less code, that's okay. That's maybe where it goes, but that's okay. That doesn't mean we're not going to still be solving the problems, developing the algorithms, creating new technologies. Maybe we just don't write as much code, and that's fine.
even if,
I'm the one that has a problem with that because I teach people to program.
but also on the other side of that, I mean, if I could jump in, the idea of like some sort of Gen AI writing its own code, you have to know how to code to identify when it's wrong.
Yeah, absolutely.
Like
Right.
that's not, it's not like,
Mhm.
oh, that's good. Let's
And
go
that's
with
not
it.
going to go away. And
No.
and GJ maybe can speak to this because we've been talking about it a lot. Um, really trying to understand that piece of it is actually pretty interesting right now.
Yeah, just to chime in, so my area of specialty is software engineering research. And in fact, I also teach the undergraduate software engineering class. So it's given me kind of software engineering is where people are saying Gen AI is going to replace all the software engineers and over and over. And, I think it's kind of caught people by surprise how good these Gen AI coding machine agents have gotten in just a short amount of time. But at the same time, I've seen enough of these kind of waves come through of, programming tools or things that enhance the programmer's effectiveness and efficiency. And to me, when I take a step back, this looks like just the next wave. Going back 10 years ago, they had little dialogue boxes and wizards that could help you construct very sophisticated systems from scratch. And just set all the code up and all the frameworks and everything that need to be created that on the get-go. I was like, oh, now what are we needed for? But sure enough, what happened each time we saw this new wave is that kind of grunt work, the simplistic stuff, we just moved ourselves up another layer of abstraction in terms of how we thought about the problems, how we solve them, and also our productivity. What I can do in a matter of hours now versus what may take me in, even 6 or 7 years ago, 3 or 4 days to code in terms of an application server or a full stack web app. Now I can do that really fast, but I've still got to be there. I just think at a higher level of abstraction about what I'm doing, what the kinds of things I'm trying to accomplish, and I'm much more efficient and productive at that than I used to be.
And I think computer science in some ways might we might get to we might get to be a little bit more of a core discipline that's interested in information theory and computer science theory and all of these more abstract, higher level ideas that are not going to go away because the Gen AI is not, it's a creation of our own. And um, you know, we're not going to stop creating. No, we're not going to stop being creative people just because the Gen AI can write some code for us.
And Paul,
Right.
I'll even suggest a next question for you. It's like, what are we doing here at USC
Yeah.
Yeah.
to evolve
Well, yeah,
our degree program?
to transition a little bit and back to the kind of the CS side of this, but I'm sure it's going to overlap into that, which is, can we talk a little bit more about the curriculum? And I think there are some jumping off points that I
Yep.
think Andrew you brought up too, which is that
Yeah.
nothing's stagnant, so what is our curriculum like? What is a student that's an undergraduate student that comes into computer science or any of our degree programs, and maybe we can touch on how there's so many different subdisciplines and specialties and specializations, emphases, et cetera. What's the coursework going to look like? And for our audience, I'll put a link in the chat right now so you all can see the 4-year plans for the undergraduate programs as they're talking. So GJ, do you want to jump in there? Sorry.
Sure, sure. I'll give it just a high level overview. So, you know, first, let me just start with the structure of the degree. We typically have across all of our different CS majors, because we actually have four of them: regular computer science, computer engineering, computer science. We have a CS with the business school, and then we have another one which is CS games. So we have four majors that are housed within our department, and typically in the first 2 years, students take a very similar structure of computer science courses. You think of this kind of as our foundational courses. There's one line that goes 102, 103, 104, 201, essentially teaching people how to program before they go into the upper division 300 level classes that are going into specialty topics like robotics, software engineering, operating systems, networks, and machine learning, artificial intelligence, deep learning, all of these different areas of computer science. And at the same time, there's another track that is in 170 and 270. And this is teaching the discrete math, the algorithms, the styles of computational thinking that are inherent in a lot of problem solving that we do in computer science. And so we're making sure people have both these twin foundations as they're moving up into our upper division. And then once you get there, then, the specific courses that are required vary whether you're in one of those four majors I alluded to, what electives you would take or what elective options you would have. That's where it starts to differ based on your degree. I also want to just kind of pivot back to just talking about how we're evolving curriculum too. I think initially when maybe 2 years ago, when all of a sudden a lot of these Gen AI code tools became available to a lot of people, we were sat back there, we were thinking, oh no, this is cheating. We have to stop this. And how do we keep this, set up the walls around our curriculum and our classes? And I think after about a year, most of us realized that this is a tool. And the future software engineers are going to be using this tool in order to create systems. And so we've evolved towards how do we ensure that we teach people basics while then also enabling them to use these tools and eventually apply them to a lot of the problems that they're going to see in the upper division courses. And so what we're really evolving towards now is 100s that are level classes that are teaching these basics, these core ideas, making sure people know them independently of external assistance. A 200 level where they're starting to learn how to use these tools effectively to actually do application development. And then finally, in the 300 level, it splinters into many different topics and categories. So each of those is handling it a little bit differently. For example, what I do in software engineering is going to be different from what the professors who are doing operating systems are going to incorporate into their approach. But I'll stop here because I want Andrew you to get a chance to chat your perspective.
Sure. I mean, so that there was a good overview of the sort of the path you'll take as a student. But I'll just comment on, I already think that, in this this fall semester that we have, students are taking a very interesting perspective on these sort of tools, and they are trying to, at least in the classes that I'm teaching, learn to program so they have the fundamentals, so that as they go on to their upper division classes, if that coursework says no, we need you to understand this material at a very low level. So we're going to discourage the use of AI tools versus some of our other courses where the professors are encouraging it because, like GJ said, it's a tool that we need to know how to use. So we have a very, if you look at it from the outside, we have a pretty typical computer science curriculum. We teach programming, we teach discrete math, computer science theory, and then we give you all of we give you a good breadth across networking, AI, operating systems, and then allow you to go on to the tech electives where you can try to find electives that match, what you're interested in computer science.
To dive in a little bit more, this is kind of resurrecting an earlier comment, but I wanted to talk about it in respect to the curriculum. In my experience of working with students, I tend to see two versions of students on either end of the spectrum. And so I'll speak in kind of hyperbolic terms. I see the student that says, I already know all this. I've been coding forever. Or, oh my God, I don't know anything. Why should one not feel so cocky, and why should the other not feel so scared? How do we talk to both of those ends of the spectrum?
Yeah.
So our progression, let me talk to the end. In fact, a lot of people come to college and are interested in computer science, and they have not taken computer science in high school.
Yeah.
That's actually very common. And because people often, you're in a high school where you don't necessarily have somebody that has the right training to teach computer science.
Yeah.
We actually adjusted our curriculum to essentially provide two different ways into our intro 100 level courses. In fact, 102 is required. It's our first CS course that's required in the sequence. And it's a gentle introduction to programming. And this is intended for people who have not had any computer science background. And we feel this is a good way to get people familiar with the basic concepts of how code works, of how strict and formal you have to be. However, we know that people who have come from a high school background where they've been exposed to these classes are going to not find that course challenging. And so we have a placement exam, or alternatively, if you've already taken AP Computer Science in high school and gotten a 405, then you are placed automatically into the second course of the sequence. But you progress through the sequence quite normal and quite straightforward way. And then you have the same access to the upper division classes that you would, regardless of which of those two courses you started from.
And maybe speaking to the other end, students that come in with a good amount of programming experience, like GJ said, they can be placed into the second course in the sequence. And then, just because maybe you know something or you had some practical experience with it, it's hard to say if that level of experience matches up to the rigor that we like to put into our courses. And so you may have a little bit of an advantage. Maybe some things you've seen, some things are a little bit easier, but hopefully in general, there's a lot of deep rigor and new information that you're going to get even if you can already program a little bit in Java or Python or something like that. So we really try to make sure that just because our courses need to be rigorous, they have enough information that's foundational to where you're going to go in computer science that you'll be engaged and interested coming to class, and then hopefully doing well, because you've already shown that you have an interest in computer science with picking up some programming in high school. And then we're going to help you run with that. We're going to, get you the really deep foundational knowledge so that you can, find your place here at USC and do amazing things.
I've got two more questions related to curriculum just to kind of help add some color to this a little bit more. I'm going to compound the question into one, which is, can we talk a little bit more about the hands-on element? What we have about a 50-50 split on most of our degree programs about theory versus hands-on. Can we talk about how hands-on is going to be kind of persistent throughout the 4 years of the curriculum? What does that mean? What do you do? And also, can we address what I would refer to as the computer science spectrum of software to hardware? How does that, because there's always an understanding of software and hardware in all the degree programs, but some of them lean in one direction versus another. So can maybe we can answer both those questions in one. I'm hoping we
We'll
can
see.
at least.
Maybe I'll talk about hands-on.
Yeah, go for it.
Sure. Yeah.
I think that computer science especially is a form of engineering that I think has to be taught hands-on. And all of our classes do involve taking the concepts and translating them into operational code. For example, when you're doing, page lookups in operating systems, or you're working on the TCP/IP, or excuse me, the TCP handshake in networking systems, or building tests to get coverage. These concepts on paper, once you understand the basic math and the algorithms from 170 and 270, it's pretty straightforward. You can see how they're being applied in these real contexts, but I don't think people truly get comfortable with these things and understand them until they get hands-on. And that's actually the way these classes are all built. There's not many classes here where you're not actually taking the theoretical concepts you learn and you hear in lecture and not translating them into code. So I'd say if you're asking if it's a hands-on education, yeah, I would say yes, in computer science.
Yeah, one thing I'd like to say early on is that as computer scientists, we are fortunate because if you want to play around with code, you want to be hands-on, all you need is your laptop, right? We don't need an expensive lab. We don't need lab safety equipment. We don't need fume hoods. We don't need soldering irons. You just pick up your laptop and write some code. So because of that, like GJ said, most of our classes include some sort of coding component. And which is how in computer science you bridge that gap from how do I solve the problem to how do I get the computer to do it for me? And if you never do that in a practical sense, it would be hard to say that we were really training you as both a computer scientist and an engineer, because we are part of the engineering school. We are creating engineers that can solve and implement solutions to actual real world problems. So you're not going to get that just without actually writing code. And then Paul, you'd asked about hardware versus software, right? Clearly
Yeah.
a spectrum in computer science, right? At one end, we have computer science that's very closely interacting with electrical engineering. And then we have our computer science theory on the other side. We do have the computer engineering computer science degree, which was or exists to give students that are kind of right in the middle and want to understand more about that interface between hardware and software, and how some of the abstractions that we learn about on the computer science side are actually implemented and handled on the hardware side. And to say one thing, again, we keep talking about Gen AI. The way that all of this Gen AI stuff is happening is because of hardware, but that hardware is programmed by computer scientists. So there's a really good, argument to be made that students who are well versed with hardware are going to be very well employable in the next few years, because um, there's a lot of hardware being deployed. That hardware, in order to make it, worth money, right? It needs to earn its cost back. We have to write programs to run on it, and writing those programs efficiently requires a little bit of hardware knowledge. And so even in our basic computer science degree, we handle that through one electrical engineering class, and then definitely some computer systems classes that take a little bit of a lower look at how the hardware actually works.
Yeah. I think that's the one thing that everybody needs to understand, is that no matter what you do inside any of these computer science degrees, you're going to have a good understanding of both sides.
Absolutely.
And you can decide where on that spectrum you want your degree to land. If it's,
Sure. Yeah.
yeah.
Through your electives, through your choice of major, and maybe Paul, you could comment on this. Certainly a student that starts out in computer science could switch to CECS almost anywhere through the degree and still graduate on time,
Yeah.
or vice versa.
No, that's a good point. And when we think about the whole spectrum, we include the electrical computer engineering degree, which is, the ECE degree, which is, the full hardware, for lack of a better term, which also has some software in it. CECS in the middle, which is 50-50, I would call it, about hardware, software, roughly. And then you've got computer science, which is the software degree. And then computer science has the subsets of computer science business, which brings in business degree courses into that. And then computer science games, which kind of specializes all of your electives towards interactive entertainment and games and school cinematic arts, fine arts, etc. Students start our program at all of these levels and
Yeah.
end at all of these levels.
Yep.
Like
Absolutely.
people come in saying, I'm all software all the time, until they take that first EE class. They're like,
Yep.
that was kind of cool. I
Yeah.
did like soldering for a minute. I like
Yeah.
circuitry. I like the physical aspect. So they start moving down the spectrum, and vice versa. And
Mhm.
so it's keep in mind that the flexibility is key. Thank you for that.
Yeah. And
Appreciate
it's actually, I'm fortunate to have students come to me and say, oh, what should I do? I'm like, well, what do you like? What do you want to do?
Yeah.
And having that discussion about, where they should go with our degree programs is actually a lot of fun. And then they'll come back 6 months later and they'll be like, oh, I did X, Y, Z. And it's nothing like you just talked about. Um, but the Viterbi advisors and the CS advisors and everybody that help the students make their progress through their degree, they look out for the students. They make sure the students know what they need to do to find a degree program that fits with their interests.
The last thing I'll say on this, and then we'll jump into my next question, is for all of you that are going down this pathway, the one thing you all have in common is that you're all planners. You all tend to want to know exactly what the plan's going to be, what degree am I going to get. And I think the one thing that we could say is it's an experiential process. You can have an idea of what you like, but as you start going through it, as you start, experiencing courses, experiencing different, projects that you're working on, you're gonna realize that you like some things and you don't like other things. And the ideas of do you like, what we talked about before with those specializations or those electives? Like, is it more the AI focus? Is it the graphics focus? Is it anything on the back end of the database systems, like data science? And where are you going with this? You're not supposed to know until you start taking those classes, and you'll start to recognize what you actually like working on,
Yeah.
and just follow that nose.
And I think one of the things I also would like to tell students is it's okay to not know.
Yeah,
It's absolutely
probably
okay to
better,
not
to be
know.
honest with you.
Because like some students are just, you can just tell they're more stressed out by the fact that they have options
Yeah,
than anything else.
yeah.
And you sort of have to switch your mindset and think about it as the fact that there are options means you can explore, and you can learn more about what you're interested in. Because I think some students they just want it to be a little bit like, I'm going to do this, and then I'm going to do this, and then I'm going to do
Yeah,
this.
give me the map.
Exactly. And they come to USC and they find out that we allow students to branch out and explore and find their own interests, and that's absolutely okay. And it's a lot of fun to see students through that process.
Let's switch gears slightly and talk a little bit more about the research side of things. Can we talk about, maybe GJ take the lead here on this, on how does computer science view research? What are the areas that we're going into, and what does research actually mean?
So the answer is broad to your question. Let me
Yeah.
explain why. Here at USC, we probably have, I would say, 90 faculty who are doing research. We have about 40 some tenure track faculty who each have their PhD students and are doing research projects. And then we also have about 40 to 50 research faculty who are in part of our institutes, ISI and the Institute for Creative Technologies, ICT. And they're all doing research projects, and all of us work with students pretty actively. For sure, PhD students, and then many of us also have masters and undergraduates. So to try to say, here's the research we're doing when there's 90 some different principal investigators doing research is hard to paint in a broad swath. But effectively, we cover every area that is, I think, could be easily denoted, like graphics, robotics, um, let's see, software engineering, databases, information management, games. I'm gonna every area that I could think of, we have somebody who is doing research in that area. Theory, programming languages, machine learning, AI, natural language processing, and we could just keep tossing out these words and probably terms that people are familiar with. And then we have probably several different faculty that are involved in that area. And I think going to just looking at the faculty list that we have, you can see just the wide breadth of topics that we're covering with that.
Yeah.
Oh, there's another part to your question, perhaps?
No, that
I
was
mean,
it.
yeah.
But yeah.
I mean, the students might appreciate a little bit of insight, and maybe GJ, you might know this a little bit more, because I'm more on the teaching faculty side. But when you work with undergrads, or you see our colleagues working with undergrads, what is the scope of that, and like how does it sort of go for undergrads?
So there's a lot of undergraduates working in research. So most of my colleagues up and down the hallway here have undergraduates in their group, including me. And what they do tends to vary a lot. As freshmen, most don't have the technical skills to participate in all parts of the research process, but they help with running experiments, doing different kinds of data analysis and things that we teach. It's a wonderfully mutually symbiotic relationship. We want to teach the students because the more we teach them, the more they help with our research projects, and the more research output happens. So it's a really nice relationship, and often we're hoping that it lasts for longer than just a semester. That way we can get students who gain training, and as they take more advanced classes as an undergraduate, they have more technical skills in development or the specialized areas where they can start to help build the research prototypes and actually design the experiments that we're employing in our research work.
Fantastic. Moving on to our next question here. It's all about outcomes. Undergrads, and I'm not asking for data or stats, but more from the anecdotal perspective. What do you know about your computer science students and what happens after undergrad? We know that our students go on to industry, they get internships while they're here, they go on to industry. Some students go on to grad school. Some students are doing both. Can you tell some stories or paint a broader picture as to what are the types of companies they're working at? What are the jobs that they're doing? Where are they going? We've touched a little bit on this, but as far as people that you know.
Yeah, I mean, I'll start broad, and then Andrew, if you want to fill in with some fun stories from all students. I think at a national level, we are one of the top feeder schools for computer science, for software engineers in Silicon Valley. So most of the big tech firms that are famous that you would have heard about, those are the ones that are coming here and recruiting our students. And I think, as I mentioned, in the top four for that. In general, our students are very well trained. They have a lot of experience doing programming, advanced systems development, and also the underlying theory. So that makes them both very impactful from day one, but also equipped with the skills to continue to be productive as things change. And the language, the framework may change, but the underlying theories do not. And so that I think our students are very well equipped and as a result have been very successful.
Yeah, I mean, I certainly have undergrad students who have gone on to master's and PhD programs at schools all over the world. In fact, um, I, you know, I write recommendation letters. I've written recommendation letters for like government agencies. I've had a couple of the reference phone calls for the security clearances. So we have students that are going into the national security and other industries that require security clearances. I've had a few students go into the entertainment industry, which is a local industry here in Los Angeles, that I did some work in my background. So it's fun to help students find jobs there. I have at least one student who's working at a really cool space startup where their idea is to do like space delivery. Um, so pretty much any field, um, we can send students there. And I definitely do get emails from students like, hey, this is what I'm doing now. This is really cool. Thanks for Teach Me 103 because I used XYZ yesterday. And it's like 10 years later, but they were in a meeting and they like were able to contribute because it's something we talked about in intro programming. So I really enjoy that. It's a lot of fun to get that sort of feedback. But if you're thinking about other majors, you're trying to think of what you might do in college. One of the really cool things about computer science, and I actually think this is where one of the places we can continue to make an impact as the field changes, is we can go and help out or work at a company in any industry. Every industry on this planet right now is using computers to do something. And you can work in healthcare and help doctors diagnose cancer better with AI. You can work in the automotive industry. You can work in even agriculture and things like that, where they're trying to figure out how to increase harvests and use satellite photos for yield. And we have students I know that have worked on and gone on to work in companies that help governments do planning for fire suppression and other environmental concerns. So the fact that you know how to take some data, analyze it, present that data in a way that helps people make actionable decisions means we can do whatever we want. Whatever industry you think you can find a cool job in, there is a computer science job in that industry.
To bounce off of that, I mean, the any industry is, I think, important to understand, because a lot
Yeah.
of students come in saying like, oh, I have a computer science degree, therefore I'll work at a computer
No.
company. And sure, our grads go on to work at Apple and Amazon and Microsoft and Meta and Google and everything in between, but they also are heavily recruited by the finance industry. They're
Bloomberg
heavily
is a big
recruited. What's
recruiter.
that?
Bloomberg is a big recruiter.
Bloomberg hires a lot of CS majors. Intuit is basically a fintech company. All these fintech companies or finance companies creating their own fintech
Yep.
subdivisions. Healthcare, the aerospace industry. It goes on and on and on and on, because, as you mentioned, this is something where everything's running off of some sort of software hardware combination. And computer science students are going to be needed across the board and will perpetually be needed
Yep.
as they all
Absolutely.
start developing. Even when we're talking about AI or LLMs or whatever it is we're going to get into, your point earlier about these quote unquote what I call retail AIs, the Chat GPTs, the Geminis, the Claudes, the Groks,
Mhm.
all that other stuff, is nothing compared to the proprietary stuff that is running under the hood of everything
Yeah.
else that's out there. And that's where most of this development is going to be pushing and pushing and pushing, and we're going to need new educated people to go into that world, and that's what
Yep.
we're doing. This will be my last question. And after I ask this question, I'm going to open up the Q&A. As a matter of fact, I'll open up the Q&A now. So you guys can start asking your questions, but I'm going to ask my faculty one more question as you're asking those questions. Here's a key point about that Q&A. It's at the bottom of your Zoom screen. There's a Q&A button. Hit that button. Start typing in your questions. ask as many questions as you like, but I would limit it to one question per entry. So meaning like if you got two questions, type the question, hit enter, type another question, hit enter, because then this is a democratic process that as the entire audience can upvote those questions. So we're going to answer the questions that are pushed all the way to the top with the most upvotes. So it's up to you all to ask the questions, up to you all to upvote the questions. So my last question before we dive into the Q&A is about the future. We kind of chatted about this, but I am kind of excited to hear your perspective on what are you most excited about in the future of computer science for maybe the next 5-10 years, GJ?
I think at the moment it's kind of almost feels like I'm contrarian to say I'm so excited for what's coming next in computer science because everybody's got a lot of doom and gloom about it. But I think that the what we've seen with the LLMs and the generative coding agents is this essentially this opening of a new way to easily communicate with AIs and to harness the power of being trained on uh, I don't even know what the right words are for the numbers, that large amount of data. And just to see how this is going to be harnessed to do things that were previously really hard to do. And that really makes me excited because I think we see this as it's going to replace jobs, but or it's going to eat my share of the pie. But I feel like what's going to happen with this is the pie is going to get larger. There's going to be more things that we can do now that we have these kind of AIs that can automate some of the basic things like recognizing natural language and text and how we're able to apply that and use that in so many different ways. For example, in software engineering, we found tons of different ways to apply this kind of computational power to problems that we have struggled with. And all of a sudden, now we can make progress in those. I know eventually we'll run into some barriers, but hopefully somebody has some new thing that at that point we can then take advantage of.
Mine is a bit more practical because I think it just illustrates exactly what GJ was saying. I love robot cars. Waymo, being able to get in a car and have it take you somewhere and not have to drive, I love it. I can't get over how cool it is because it's one of those things where you as an engineer and a computer scientist, I know enough about what it took to get there that it just blows my mind. To sit in that car and trust it to drive me around Los Angeles makes me excited because what's next? Like, what is the cool thing that's going to happen next? And like just exactly like GJ said, the LLMs are not going to they're not going to create the next cool thing. Somebody is. Someone's going to figure out how to do something really cool. And sure, the LLMs or these other things might be part of it. And maybe it happens faster because now programmers and computer scientists can work faster, and so we can get towards those really cool new things faster. And the Waymo, the robot car, is just the way I illustrate that because it was promised for so long, and it took so long and so long and so long, and then all of a sudden it switched, and now we have those cars. They exist. You can drive them around. Or sorry, you don't drive them around. They drive you around. And I just love it. It's just a great, as a tech nerd engineer, I just love it. It's so much fun.
Awesome. So now we move on to the open Q&A feature for our audience members. As a reminder, the Q&A button is at the bottom of your Zoom screen. Click there, keep typing questions, keep asking questions, keep upvoting, because the more you upvote, the more we're going to be able to get to the ones that you want to hear. As a reminder, we're not going to be asking admission questions or application-based questions because we have plenty of admission events for them. This is the only event that we have with our faculty, so we're going to be focused on the discipline, the major, the curriculum, the classes, the research, everything that comes into computer science. So please, let's upvote those things, and we can talk about admission in a separate session. I'll put a link into the chat about our events for admission. But the first question, undoubtedly, is about admission. Nathan asked this question, even though I said, but it's an important question I think we should talk to. So first off, Nathan's asking, is CS an impacted major at USC? No, we don't have any impacted majors in the Viterbi School of Engineering. That's the optimistic way of looking at it. You can also look at it cynically. Every engineering major is impacted. The answer is the same. What that means is that it's not any more difficult or easier to be admitted to one major versus another in the Viterbi School of Engineering. When it comes to your admission process, you should be going after the thing that you are most interested in. You're not going to be, your chances are not affected based on particular majors that you put down. And when you're admitted to any one of our programs in the Viterbi School, as we talked about before, flexibility exists. If you realize you're in the wrong one, you switch to the other one without any friction. You don't need to worry about it. So Don't worry about it when it comes to the application process. Choose the thing that is most interesting to you, and we'll get you into it right away, and we'll admit you and get you started. So our next question is from Zane. In terms of student outcomes, is it better to focus on one area, such as CECS, or the junction between two, I'm sorry, such as CS or ECE, or the CECS, and how does industry view each of these kinds of degrees in comparison with each other? I'm going to let you all jump in a second here, but the answer is no. Pick the thing that you like the most. All of these students get jobs, and sometimes they're working side by side. So it's just much more a question of what you think is interesting to you. And it looks like you're going to jump in on that.
I mean, I would say some of the most successful, best software engineers I know now were my friends from EE undergrad. So engineering is about learning how to use your skills to solve problems, and going to college is about learning skills that you're interested in using. So pick something, you will get a job doing something cool, and you don't have to worry about exactly which classes did I take. Did I take that class or that class? I don't think it matters.
Yeah, they're all good degrees. And I think that choosing the one that sounds most interesting to you is the best for you because you're going to do the best in those classes. You're going to
Yep.
care about the work.
That's the biggest correlation that I want all of you to understand is that you are going to be most successful in the area that you enjoy the most. And if you go towards something because you think you have better outcomes in that, and it's not right for you, you will not be successful in it. And we see that a lot. Go towards the thing that
Yeah.
you want to do. This is not a mathematical problem. It's much more about, I don't know.
And another way I put it for some students is you need to find something that you want to do for 4 years. Don't worry about what you're doing for the next 20. That'll take care of itself.
That's a good point. Next question is coming from Ayush. Ayush is asking, is there a way to combine AI and art into interdisciplinary research at USC? So first and foremost, let's talk about your undergraduate curriculum, because the majority of your time is spent taking classes, doing homework, doing projects and that, and research is on top of those things. So first, the idea that you can take AI classes, focus on AI in the CS degree program. We also have our new AI degree, which we're having that session next week. If you want to pop into that to learn about that degree program and understand the differences between it, one is not necessarily right for another. Just check that out. And the idea is that any major at USC can also take different classes across the spectrum here at USC. So the ideas of an art student taking art classes, taking dance classes, music classes, you can do that and kind of create, to Professor Goodney's point of worrying about your next 4 years and how that's going to be interesting to you. Well, maybe that's a combination of these types of classes. And so I would say that your experiences and your time in your undergraduate years can be whatever you want to be in any interdisciplinary fashion as you go through that. And research is, I think, the next thing. And research is also focusing on things that faculty are doing and supporting those faculty. But do y'all want to jump in on this?
I was gonna say, like, specifically answering that question, I'm sure that somebody is doing some work across the intersection of AI and art. And, it's a big deal about AI and art. And is AI stealing from artists? How does that work? And how do artists feel about, making new contributions if the AI is just going to steal it? And those type of ethical uh, ideas that intersect with computer science, I'm sure someone at USC is working on looking at those type of problems. And, you know, 90%, 99% of the time, our faculty loves working with undergrads, and no matter where they are in the university.
Yeah, USC is a big place. So even if I can't point you to a CS faculty person who's doing AI and art, probably if you and I went and looked and through everybody who in the Department of Art History or anywhere like that, we're going to find somebody who's intersecting with that, or who would consider their research to include that area.
I mean, we certainly even have the Ivy and Young School, right? So we have a whole school dedicated to the intersection of tech and design and art.
Yeah, and you can take minors in that program. You could just take a few classes in any of these programs. I mean, really, so many times students ask me about programs, and I always say we don't have programs because you could do whatever you want. You build your own program.
Yeah,
You get your
yes.
degree program, and you add on top of that. Take, that it's your life. Choose how you want to do that. This almost blends exactly into the next question that's pushed to the top from Anushka, which is, can you please expand on how students explore interdisciplinary interests on campus? We just kind of did that, but the ideas of taking classes however you wish on top of your degree program. Sometimes students kind of blend these things together, maybe through the concepts of directed research if they wish to do so. Oftentimes, this kind of happens in hands-on projects as well. You know, when students are taking those software engineering classes or the large software systems. I'm blanking on the name of the class, where they're kind of working as consultants and working to
401, so the capstone class, probably.
yeah, and can we talk a little bit about that class and how they're kind of working to create kind of
Sure,
solutions?
yeah, maybe I think GJ knows more about
GJ?
that class.
Yeah, sure. Yeah, so 401 is our capstone course. And actually what's really interesting is it takes real projects that are coming in from people who are not, it's not like a class project where it's kind of contrived and artificial in some sense. This is real people, real groups, real organizations coming with problems that they think can be solved through the application of computer science, software engineering. And they come to 401, and there's actually is the capstone where the students, after they've gone through almost every class in our curriculum, now it's their time to take all that and apply it to solving real problems in a slightly managed setting. So it's not, as brutal as it might be in the real world, but there's guardrails, but they're there to solve these kinds of problems. We're also seeing a lot of really interesting interdisciplinary work going on is in the student clubs, because often those are formed around solving problems in particular areas. And they involve people who are domain experts in maybe the particular kind of robotics or the particular kind of automobile. And then they involve computer science people, they involve mechanical engineers, people who are experts in human interfaces. And you see a lot of this kind of interdisciplinary work getting in connections being built there. And I think that's really a great experience for our undergraduates.
Great. The next question is an admission question, but I think it's an important one to answer. It says, will the CS faculty be involved in the admission process, like, for example, to evaluate student research papers? No. And I think that this is important to understand because what's implied there is that you experience is points in the application process, and that is not true. We're not looking for students that have experience in CS over others that don't. We're looking for all types that are coming into this, but also we're part of this process in the Viterbi School. We are evaluating those applications, we're understanding those applications, but to understand preparation for the program really comes down to math and science preparation from your high school, not just something that you did extra on top of that. And we're looking for students to kind of create this entire student community, which is lots of different types of individual personalities, not just people that are like so dead focused on one thing. So stuff that you've done is definitely important. Make sure that you're including that in there, but we're also not looking for you to add links to research papers. We don't want that. It doesn't really help us. You can explain what you've done and give us all those different opportunities. But also some of you haven't done any of that. Some of you are just super involved in band, and maybe you've spent hours upon hours involved in marching band. That is valuable as well to our community. The ideas of different people doing different things is what we're looking for. So let's not worry too much about any of that stuff. Just make sure that you get your application done, and the Viterbi School will be involved in that. Next question is coming from Nathan Hunt. What are the project teams or professional clubs that a student can participate in as a computer science student?
There's a link off our website.
Yeah, I was going to say the answer is yes.
Yeah, it's a huge list.
It's a huge list.
Yeah.
And it's a great list. A lot of the clubs come and talk at the beginning of my classes, at the beginning of the semester because they're recruiting. So the easier way to answer it is pick an area and there's a club doing it. But of course we have some famous ones like the RPL, which is the Rocket Propulsion Lab. We have Lava Lab and Scope, which are kind of more kind of consulting focused clubs. We have Makers, which is one of my favorite clubs where the students build projects and they do it just for fun. Some of them are silly, some of them are artistic. So we have a lot of students that are involved in a lot of clubs. I think it's one of the great things about the Viterbi School. And I think you just have to do a little bit of legwork. There's a involvement fair, right, Paul, in
Yep.
the fall, where you can walk past the clubs that are, having a table out to recruit and just go from there. Just, be willing to put yourself out there and spend a little bit of time finding the club that you might be interested in. But there's tons. I would say tens, if not hundreds, but it's probably more like,
Dozens.
dozens. Yeah.
This is a good number.
Yeah.
I think what's important in what Professor Goodney just said is that yes, there are certain disciplines or professional teams and organizations that are related to computer science, like the Association for Computing Machinery or SCOPE or Code the Change, any hackathon groups, Athena Hacks, all these different groups that do that. But even the first off of his list were non-CS related stuff. You don't have to be doing CS all the time. If you want to get involved in Rocket Lab, they need computer science people involved in that too. You want to get involved in SC racing, they need computer science, and maybe it has nothing to do with computer science. Maybe you just really like cars and you want to get involved in designing and building a formula style race car from scratch every year. That's fine. We don't have rules. We don't have specific columns or pathways that you have to live within. And also we don't have a competitive nature among these clubs and organizations that many other engineering schools are coming to bear now. Like you don't get into the school then hope you can get into the organization. They're all open for you. So you can jump into that and get involved and really expand upon your educational process, not only in building community, but also building this new technical knowledge that you can apply right from the get-go. Here's an interesting question. Miles is asking, what are the differences and similarities between majoring in our new AI program and majoring in CS? And in addition to this conversation, again, I encourage you to check out the AI faculty roundtable that we're having next week. You can sign up on the same page you sign up for this, so you can kind of get all the perspectives. But how do we talk about that?
Sure. I'll be able to try on that one. The computer science degree, I think, is a very generalized degree in terms of what it prepares you for doing, in the sense that you get exposed to a lot of the key areas of computer science, like operating systems, theory, software engineering, networks, artificial intelligence. And so you take generally an upper division class in each of those. In contrast, the BSAI, you're being prepared to take a lot of upper division classes that are exclusively in AI, and not being prepared as broadly in computer science. So in the BSAI degree, you have a certain subset of electives that you can take depending on which of the tracks you go into. And those are, one I think is the analysis, another one is the more hardware oriented, and another one's the more software oriented one. And within each of those tracks, you have a set of electives, but you can see what those are in the course catalog. And in computer science, your electives and your required classes are much broader in scope and not just in AI.
Great. The last question that we will handle today is all about computer science games. This is a specialized degree program in the computer science department, and it's asking about the companies that partner with the school, offer internships. In addition, first and foremost, computer science game students don't necessarily work for games companies, right? They're still being hireable by other disciplines that we all talked about, and especially gaming divisions inside of these larger companies. But just a few companies off the top: Riot Games, Electronic Arts. I know there's a lot of different mobile game companies that are involved as well that get involved.
Even Microsoft.
I'm sorry,
I've had some CS game students go to Microsoft. Absolutely.
Yeah, does Microsoft own Blizzard now? I forget who owns who
And
now.
Xbox, of course, too. So
Yeah, Xbox. Yeah.
So
Yeah. So it's really across the board. Anything else you guys want to talk about when it comes to games, CS games?
No, I mean, they have a big expo every year
Yeah.
where they showcase all the games, and it's open to industry. So, we have a huge economy here in Los Angeles with entertainment/games. And those companies just show up at this expo because the games the students are producing in this final game project class are professional level. So they walk around. I've even downloaded some of them and played them myself because they're really fun.
Yep.
So you can go and you can check those out. And a lot of companies are doing that, coming in and recruiting right out there based on what they see.
Yeah. And I'll just say that the CS game students have a lot of fun. They work hard, but they have a lot of fun.
All right. Well, on that question, we've wrapped up into our hour, and I want to thank all of you for joining us. If you would like to join us for any other admission events, I put a link in the chat, viterbi.link/events, if you'd like to check out any of our in-person or virtual events that are coming up. In addition to, we have one more faculty roundtable next week, which is the artificial intelligence one. You could check recordings of all of these, including this one. If you missed anything, will be on our YouTube channel. We'll probably get this recording up sometime by the weekend here. Last but not least, I'd like to thank our faculty, Professor Goodney, Professor Halfond. Thank you so much for joining us and representing the department today, for all of our students that are interested. And don't miss our application deadlines. And so that's really what's coming up last. Thanks so much, folks. Have a great rest of your evening and a great weekend. Bye-bye.
Thank you.